position versus time graph. This happens to be sample letter A, and this was worked on in class on February 2nd and 3rd. You might want to use this to help guide you through the homework that's coming at you. For number 1, it says label the axes, use seconds or the units on each axis, label seconds with S and M for meters. And remember, if I go too fast on any of this, you can always pause and rewind as we go through. So for starters, position is measured in meters, while clock reading is measured in seconds. For the velocity versus time graph, time is still measured in seconds, but velocity would be measured in meters per second. Please keep in mind that even though these graphs are not sketched out quite perfectly, the intent is not to trick you, that the starting position is 4 meters and that at 8 seconds it reached a corresponding position of 20 meters. So as we go cranking through this, it says what's the y-intercept with units? Well, 4 meters is the y-intercept, and what does that tell us about the motion of the object? Well, for all graphs, for y versus x, the y-intercept always tells us the y when the x equals 0. So in this case, 4 meters, it tells us the position when the clock reading is 0, or it tells us the starting position of the object is 4 meters. Now, please make sure that your specific include not only that it's the starting position, but that 4 meters is this object's starting position. Next up, we want to calculate the slope of this line. Now, even though this isn't a grid line, we can use these two coordinates as slope points as we move forward. So taking a look at this, we know that for, we're trying to calculate the slope, and that you know that that's change in y over change in x. In this case, our y-axis is position, so it's change in position divided by change in time. And I'm going to go ahead and do the expanded version of this formula. So position 2 minus position 1 divided by clock reading 2 minus clock reading 1. And our final position, or our second position, is that 20 meters right up there. And our starting position is 4 meters, and that took 8 seconds to play out from 0 to 8 seconds. So our final clock reading, our second clock reading is 8 seconds. Our initial clock reading, or clock reading 1 is 0 seconds. So as we simplify those, 20 meters minus 4 meters is 16 meters divided by 8 seconds. 16 divided by 8 is 2, and the units are meters per second. Notice that that's a positive 2 meters per second, which tells us our object is moving in a positive direction. And so the slope of our graph is 2 meters per second, which represents the velocity, or average velocity more specifically. As we continue, what is the specific meaning of 2 meters per second? Well, we want to be specific. What does 2 meters per second represent? Well, I encourage you to take a look at the units and maybe even think about flipping them upside down, because it doesn't tell us anything if you say, well, it moved 2 meters each second. However, if you tell me for every 1 second, the position increased by 2 meters, then that gives us a better idea of what that actually means. 1 second later, it'll have moved 2 meters. 2 seconds later, it will have moved 4 meters, and so on. So, if we take that and flip that upside down, we can say for every second, the object moved 2 meters, or you could say the object's position increased by 2 meters. What's the physical significance of the slope of any position versus time graph? So in super general terms, the slopes of any position versus time graph represent the average velocity, which you could use the words, these blue right here, or the symbol for average velocity. V is speed, V with a vector is velocity, and the average velocity, it gets the vinculum of that little bar, so that's average velocity. Writing a sentence describing the motion of the object in as much detail as possible. A week ago, we didn't have numbers included, but we do not want numbers included here. So we know that the object started at the 4 meter mark. It moved in a positive direction at a constant velocity of 2 meters per second. I included the detail for 8 seconds, but the parts I haven't read up here are super important. Where did the object start? What direction is it traveling? What type of motion? And can you quantify that? Writing up a specific mathematical model. While you're not required to write y equals mx plus b, I want to reiterate that that's all we're doing with this specific mathematical model. taking a look at the graph above, the y-axis is position, the x-axis is clock reading. The slope of our graph was 2 meters per second, and the y-intercept for our graph was 4 meters. We're going to say that's the final position. So that's our specific mathematical model. Specific, it's for any position versus time graph, but specifically it lays out what the slope is and the y-intercept for that specific line on that position versus time graph. And then sketching out a velocity versus time graph, we'll have to go back and do that up on the first page. So we've got our velocity versus time graph here. It looks like 8 seconds would take us out to about here. It was a positive constant slope, and we want that to end about at 8 seconds, and we said that the slope was, the velocity was always 2 meters per second, and so that's what our velocity versus time graph would look like, a horizontal line at 2 meters per second for the 8 seconds, and then draw a qualitative motion map. Now, because it's qualitative, the actual numbers don't matter. So as long as our dots are equally spread out and our velocity vectors are all equally long, our starting position cannot be at 0. It started at 4 meters. But again, there's no numbers down here besides the 0. So you could have done this for putting 9 symbols down there representing 8 seconds, but that works. Some things that we could also have done with this that are not included in this is we could use that specific mathematical model to find the position at any clock reading, including the 8 seconds that we have, or even some time that would occur later. So for instance, what if we ran this thing for like 12 seconds? So if the time was 12 seconds, how would this look? Well, we could say position final equals 2 meters per second times the 12-second clock reading plus our starting position of 4 meters. According to order of operations, we'd have to multiply these in first. So 2 times 12 is 24 meter per second times seconds. So the seconds cancel out. So we end up with 24 meters plus the original 4 meters from the starting position. So at 12 seconds, this object would have reached a position of 28 meters. We also could have gone up to the velocity versus time graph and said use the area under a velocity versus time graph to find the displacement, in which case we'd say the area of the rectangle is equal to the height times the base, which in this case is the starting velocity times the change in time. Our starting velocity was 2 meters per second, and that lasted for 8 seconds. So 2 times 8 is 16 meters per second times seconds. The seconds cancel out, leaving us with just meters. And what does that represent? It would represent the displacement for those 8 seconds. So there's just some couple other things you could have done with that. I hope this helps.